First, we are going to practice mole conversions. Here I've used the problems from our study guide from this unit, so if you would like to pull that out and reference it, that would help. This is number 2, and we are going to calculate the number of grams in 4.7 moles of K2SO4. Now, using this little chart that Ms. Williams gave us, we know that to go from moles to grams, we need to use the molar mass from the periodic table. Knowing that, we find that the molar mass of K2SO4 is 174.3. So to set up our problem, we're going to say 4.7 moles of K2SO4 times 174.3 grams of K2SO4, because that is the unit that we would like to convert to, over 1 mole of K2SO4. And when we calculate this, we find that there are 819.2 grams of K2SO4 and 4.7 moles of K2SO4. Next, we are going to practice balancing equations. This I also used from the study guide, and this is letter A. So, one tip that I use, that Ms. Williams taught me actually, is list the elements under the equation, and on each side you count how many there are of that element. So on the left side there are 2 Fe, and on the right side there's only 1. On the left side there are 3 oxygens, and on the right side there's only 1. Now, our mg's are already balanced, so on each side there is 1. So we know that to change this to 2, we have to multiply the 1 by 2, so we add a 2 here. Now our Fe's are balanced. Iron, that is. Now, to balance our oxygens, we need to multiply this by 3. We need to put a 3 here. Okay, so that changes that to 3. Well, now that messed up our magnesiums. So now we have 3 magnesiums on the right and only 1 on the left. Now, since magnesium is by itself, it makes it easy, so we just add a 3 here. And now we have a balanced equation. Now we are going to practice plain old stoichiometry. This I also got from the study guide. So here we have a balanced equation, and our question is asking us how many moles of aluminum are needed to react with 9 moles of oxygen. So think back to when we practiced mole conversions, and I showed you this chart. So from this chart we know that if we are trying to convert from 1 mole of one substance to another mole of another substance, we use the coefficients from a balanced equation, which we have. So we are going to set up our equation. So we know that we have 9 moles of oxygen times, and oxygen is going to go on the bottom because that's what needs to cancel. So from our balanced equation we have 3 moles of oxygen, so 3 moles of oxygen. And the substance that we are converting to is aluminum, and we have 4 moles of aluminum. And when you calculate this out, 9 times 4 divided by 3, you get 12 moles of aluminum. So that is our answer, and we know that you need 12 moles of aluminum to react with 9 moles of oxygen, and that is stoichiometry. Now we are going to practice molecular and empirical formulas. So I know this is a lot of words which we will use as we go, but now our question asks, it says a substance is 94.4% carbon and 5.6% hydrogen and has a mass of 178 grams per mole. What are the empirical and molecular formulas of the compound? So if we go back up to our steps, we write each percent as grams. So we're going to start with carbon. So we're going to take 94.4 and turn that into 94.4%, which we get from here, and turn that into grams. Okay, and we're going to convert that to moles, as our second step says. So we have 1 mole of carbon, and sorry, I should have put carbon here. The molar mass from the periodic table of carbon is 12.01 grams of carbon. So that gives us 7.86 moles of carbon. Okay? So now we have to find the moles for hydrogen. So we have 5.6%, which we're going to make into grams, once again as our step says. And now we're going to convert that to moles as well. So we have 1 mole of hydrogen, and the molar mass from the periodic table of hydrogen is 1.008, and that gives us 5.56 moles of hydrogen. Okay, now our next step right here, it says divide by the least. So this is our least amount of moles between the two. So we're going to divide 7.86 by 5.56, and that gives us 1.5. We're going to divide 5.56 by 5.56, which gives us 1. So now we have our empirical formula of C1.5H1. Now we know that we can't have whole numbers because in our steps it says to make, we can't have half numbers because in our steps it says to make all subscripts whole numbers. So in order to do that, we're going to multiply this whole thing by 2, which gives us C3H2. And that is our empirical formula. Now for our molecular formula. So here is our formula to find the molecular formula. And it says that we need to take the molar mass of the molecular formula, which we get from right here, which is 178, divided by the molar mass of the empirical formula. So we have to find the molar mass of this right here, which is 38.05, which we get from the periodic table. And when we divide this out, we get a whole number of 5. Now our last step right here says to multiply the empirical formula by the whole number, which we have right here. So we're multiplying this empirical formula, C3H2, multiplying this whole thing by 5, which will give us a molecular formula of C15H10. So here we have our molecular formula. So you have your empirical formula here and your molecular formula here, and those are the steps. Now we are going to discuss how to find the limiting reactant. Here I have listed the steps to find the limiting reactant, and this is a problem that I got from our stoichiometry notes PowerPoint. It's on page 12 in the bottom right, if you would like to follow along with me. Alright, so let's read our problem. Given the reaction CH4 plus H2O, which produces 3H2 plus CO, if 15 grams of each reactant are combined, how many grams of CO will be produced? Okay, so we know that we have 15 grams of each reactant. Reactants are on the left side of the equation, so we have 15 grams of CH4 and H2O. Alright, so let's look at our first step. It says convert all given values to moles. So our given value is 15 grams of CH4 and 15 grams of H2O. We need to convert both of those to moles. So let's start with CH4. 15 grams of CH4 Okay, so we have 15 grams of CH4 and we're converting that to moles. So 1 mole of CH4 over the molar mass of CH4 is 16.04 grams of CH4, and that equals 0.94 moles of CH4. Alright, so now for our other reactant, we have 15 grams of H2O times 1 mole because that's what we're converting to, over the molar mass of H2O is 18.02 grams of H2O equals 0.83 moles of H2O. Okay. So now that we have a molar value for both reactants, we can go to the next step. Divide each value by its coefficient. So the coefficient of CH4 is 1 right here. There isn't 1, so we know that that's 1. So we can divide 0.94 by 1 and we get 0.94. The coefficient of H2O is also 1. So divide that by 1 and we get 0.83. Now let's look at our last step. Whichever value is the lowest is the limiting reactant. So here is our lowest value. So we know that H2O is the limiting reactant. Okay. So we have our limiting reactant, but the question is also asking us how many grams of CO will be produced. So we're trying to find the grams of CO. Well, we can use this mole value right here